Alright, so we're going to look at solving general equations, and we have a couple of properties we can use to do this. The first property that we've already talked about is the addition property of equations, which says that if you have two things that are equal, and if you add the same thing to both of them, they'll still be equal. This also allows you to subtract something from both sides of your equation, which really means just you're adding a negative. We're going to use this typically to get rid of entire terms. If we have a term we don't want, we will use the addition property by adding the opposite or subtracting if necessary. The other property we have is the multiplication property, which says, likewise, if you have two things that are equal, if you multiply both of them by the same thing, you still have an equality. There is a restriction. You can't multiply both sides by 0 because that will make both sides 0 and it won't really prove anything. This also allows you to divide both sides by a number. Again, you can't divide by 0. And again, when we just say divide by 0, we mean multiply by the reciprocal. But just shorthand way, we say divide by 0. And we're going to use this typically to, if we want to eliminate part of an expression, we don't want to eliminate the whole thing, just a piece of it, we'll use this multiplication property. And again, terms are things that are added to make an expression. So let's look at the steps we will use. And these are kind of the basic steps. First thing we want to do is make sure both sides are as simple as possible. So combine like terms, distribute, whatever you got to do, each side individually to make it as simple as possible. The next thing we want to do is make sure there's only a variable on one side of the equation. So if we have variables on both sides of the equation, we're going to use the addition property to eliminate one of the variable terms, the entire term, not just the coefficient, but the entire term, so that there's only a term with a variable on one side of the equation. And then we're going to try to get that remaining variable alone. So we'll try to get rid of any constant terms with it, and we'll try to get rid of any coefficients that are with it. So let's look at a few example problems to see how this goes. So we'll start with something like this, kind of a basic type of general equation, 3x minus 5 equals 10. So some things we notice about this. First thing, both sides of the equation are already simplified. There's nothing, no terms to combine, no distributing or anything. And we also have just a variable on one side of the equation, on the left-hand side. And typically we like to have the variable on the left-hand side. It's not required, but you'll notice I'll keep doing that throughout this video. But you could also have variables on the right-hand side. That's fine. So all we need to do is get that variable by itself. So first thing I want to do is get rid of that constant value. And so we're going to add 5 to both sides of the equation. That'll cancel out negative 5. And now I just want to get rid of the 3. So again, remember, if I just want to get rid of a piece of it, I do that by multiplying or dividing. So I just want to get rid of the coefficient. I'm going to divide both sides by 3. That'll make 1. That'll eliminate the 3. And that'll leave me with my answer, x equals 5. Okay, so here's another problem. I have x's on both sides of the equation. So it's already simplified. Both sides are already as simple as they're going to be, but I have this problem where I have x's on both sides. So first thing I need to do is get rid of one of those x terms. And I'm going to get rid of the 7x on the right-hand side. You could just as easily have gotten rid of the 4x on the left-hand side. This is just a personal choice I made. So I'm going to subtract 7x. Remember, when you want to get rid of the whole term, you do that by adding or subtracting. So I'm going to subtract to get rid of a 7 minus 7 will make 0. And that's going to give me negative 3x minus 7 equals 10. Now this looks like the first problem. So same process, get rid of the constant term, add 7 to both sides, and now we want to eliminate the coefficient, so we're going to divide both sides by negative 3, and that will give our answer, x equals negative 17 thirds. This is okay to be an improper fraction. It doesn't have to be turned into a mixed number. There may be some question about what format you might want to write the answers in. If it doesn't come out to be a whole number or an integer, then the typical rule is if you have fractions at the beginning of the problem, you like to write the answer in fractions. If you have decimals at the beginning of the problem, you like to write the answer in decimals. In this case, we had neither one. All we had were integers. So it's up to us, but 17 thirds does not come out to be a nice decimal. So leaving it as a fraction would probably be the best choice. Let's look at this problem. Notice this one, both sides are not simplified at all. So that's the first thing we need to do. And we're probably going to do distributing. So we're going to distribute the 5 through the first parenthesis, 5 times 2x, 5 times 3, and then we're going to distribute that negative 4 through the second parenthesis. Negative 4 times 7, negative 28, negative 4 times negative 2x, positive 8x. Then what we want to do is clean up both sides. Now if you look on the left hand side, 10x plus 15, that's as neat as that side can be. But on the right hand side we have 6 and negative 28. They can be put together, so let's do that. Combine like terms. And I just put the 8x before the negative 22. You don't have to do that at this point, but you should get in the habit of always putting them in the correct order. So now again I run into the problem I have x's on both sides, and so I need to get rid of one of the variable terms. Again, I'm going to choose to get rid of the one on the right. Again, you don't have to do that, but that's the choice I'm making. So I'm going to subtract 8x from both sides. To get rid of a whole term, you add or subtract that term, the opposite of that term. That gets rid of the 8x, so I get 2x plus 15 equals negative 22. And now we're back to the same old, get rid of the constant term, subtract 15 from both sides, and then get rid of the coefficient, divide both sides by 2. And that gives us our answer. And you notice this time I wrote it as a decimal. So if you look at the original problem, just integers, we could do fractions, we could decimals. Just to kind of change it up, because 37 divided by 2 turns into a reasonably nice decimal, I just said, yeah, sure, I'll write it as a decimal. It was up to me. It was my choice. I chose that option. Alright, so here is another problem, and this one's a little different than the other ones, but the process is similar. We want to simplify both sides, so we want to distribute. And remember, when you multiply a fraction times a whole number, always think of that whole number as over 1. So fractions, numerators together, denominators together. So 2 times 7 is 14, 3 times 1 is 3, so 14 over 3x, and so on. So 14 thirds x, 2 thirds times negative 1, negative 2 thirds, 1/4 times 3x, 3/4 x, and 1/4 times 5, 5/4. Now, because this is an equation and not just expressions, we have an option that we don't have with just expressions, and that is the multiplication property of equations. Now, regardless of how we're going to do this, what we want to do probably at this point is figure out what the least common denominator is, and since we have 3's and 4's, the least common denominator would be 12. So what I can use is I can use that multiplication property of equations to multiply both sides of the equation by 12 over 1, this least common denominator over 1. The reason why is if you multiply that times every one of these fractions on both sides, you had to multiply it times everything, so if there were any whole numbers at this point, we'd also have to multiply those. But this is going to get rid of all the little fractions. So if you take 14 times 12 and then divide by 3, you're going to get 56. So 56x. 12 times 2, divide by 3, 1 times 3 is 3, so 8, 12 times 3, divided by 4, 12 times 5, divided by 4, and notice we don't have any fractions. So that's an option that you have with equations, because you can multiply both sides of the equation by the same thing, that you don't have with just an expression. If you try to add two fractions, you couldn't use that rule. Now, just like before, we want to get x's on only one side, so I'm going to subtract 9x to eliminate the x on the right-hand side. And then I'm going to work on this 47x minus 8 equals 15 at the top here. 47x minus 8 equals 15. I'm going to add 8 to get rid of the constant term. And then I'm going to divide both sides by 47, and that'll get rid of the coefficient, giving me my answer. And again, this is a fraction. The problem is 23 over 47 does not turn into a nice decimal, so this is probably the best way to write this solution. So that's how you solve general equations.